Hi folks. When we come to do projectiles in our mechanics work, now I know this isn't mechanics, we look at something flying through the air. And what you know from mechanics there is if there's no wind resistance on that body at all, the only force acting on it is its mass. Sorry, its weight. It's got nothing holding it back if we ignore resistance. There's only its weight pulling it down. And that allows us to think about its position in a unique way. Because actually, if we separate its position in the X and its position in the Y, we can then work with the force only acting in the Y, so there only be an acceleration in the Y direction. Now, this is moving along, constant acceleration because it's only gravity that's making it accelerate. So we can use the constant acceleration formula. So if we think about S equals ut plus half at squared, if we say, well, okay, for the Y, it's got this acceleration due to gravity. So I'm going to say that Y is equal to the vertical velocity. I'm going to separate that, but that's not an important part at the moment. Times time. That's acting downwards, Y goes up, so I'm going to put minus a half gt squared. And for X, there is no acceleration, so we're just putting it in terms of time. So this bit doesn't exist for the X. So what we've got here is that Y is some function of time and X is a different function of time. Now these are called, these use a parameter of t, so are called parametric equations. Now, up on your screen you will see that you've got this question. X equals 2t and Y equals t squared. It says, oh, and it gives us a range for t. Now it says, for a start, find the Cartesian equation of the curve in the form of y equals fx. So I want y equals something to do with x. So because it's a Cartesian, which is the opposite to a parametric, Cartesian is what you normally use in the x and y axes, developed by René Descartes. So I'm going to try and eliminate the t's altogether. So here I've got t is equal to x over 2. So putting that into this one, I've got y is equal to x over 2 squared. So y is equal to x squared over 4. Okay. Now, the other thing that we need to look at is, okay, if t is between -3 and 3, then x is between -6 and 6, and that will be the domain of fx if this is in the form y is equal to a function of x, and if t goes from -3 to 3, then y goes between, you'd expect it to be 9, wouldn't you? Both of those being 9, but actually y goes from 0 up till 9, because anything squared can never be negative, and all these values in between -3 and 3, if you square them up, they come to 9. So, and then that is the range of f of x. And the final part of our question asks us to draw y equals fx. If I put my axes in here, so I've got y equals x squared over 4. I know that my range is going from 0 to 9, my domain's going from -6 to 6, and I know it's a quadratic graph, and I know it's a positive quadratic graph. So let's go from there to there. So, key things. You change a parametric form to a Cartesian form by using a substitution. The Cartesian form is the y equals fx. Previously we got y equals one function of t and x equals a different function of t. And then if you look at the range of t values that you're given, then putting those in there will give you the domain of this function, and thinking about the t values in this one will give you the range, domain and range, and therefore that will help us to draw a graph. Obviously that shouldn't be there. Okay, so substitution, think about domain and range, and that should help you to draw. Righty ho, hopefully you enjoy that, and I'll speak to you soon.